Today we're going to talk about applications of proportions. Similar figures have exactly the same shape, but not necessarily the same size. So down here we have two triangles. Okay, they're the same shape, but they're not the same size, so these two triangles are similar. Corresponding sides of two figures are in the same relative position, and corresponding angles are also in the same relative position. So notice down here, okay, the corresponding angles are color-coded, and the corresponding sides are also color-coded to match them up with each other. So down here, we're going to set up a proportion of the corresponding sides. So we are going to say that AB corresponds to side DE. Okay, that ratio right there would equal the ratio of side BC over side EF. Okay, and finally, side AC would correspond with side DF in the bigger triangle. So notice that the matching sides, okay, can be set up in the proportion. Notice the angles would be equal to each other. So angle A would be equal to the measure of angle B, or angle D. The measure of angle B would equal the measure of angle E. And finally, the measure of angle C would be equal to the measure of angle F. So when you have similar triangles like here, you can set up a proportion of the corresponding sides and the corresponding angles are equal. When stating that two figures are similar, we use the following similar symbol. Okay, so up here from the triangles above, we could say that triangle ABC is similar to triangle DEF. Notice, make sure the matching or corresponding vertices are in the same position. Okay, so in other words, A and D were matching, B and C, or B and E, and C and F were all matching positions, so they have to be in the same order when you're writing this similarity statement right here. Alright, in example 1 here, we're going to set up a proportion to figure out what X is in each diagram. So before we do that, we're going to notice the corresponding side. So notice side RS right here, okay, is going to correspond to side CB over here. So I can write that first part of the proportion. Side RS is 8, okay, and side CB is X. I'm going to say that's equal to, and now I'm going to look at the other side. I know that this side right here corresponds with this side right here. Okay, so I can say that inside RT is 5 over side BD is 12. Now we're going to cross multiply and solve this proportion. So I have 5 times X is 5X. That's going to equal, now I'm going to cross multiply the other way, 8 times 12 is 96. Okay, now we just need to solve it. So we're going to divide by 5. We're going to divide by 5 there, and we would end up with 19.2 feet. Or in other words, this X right here, it would be 19.2 feet long. Let's move on to example B here. In this one we have two hexagons. This hexagon is similar to the other hexagon. So we're going to take the same idea with this one. Okay, so notice these two are similar, so you can match the corresponding sides. So I'm going to pick that side right here, which is 2 centimeters, side KJ. okay, would match up with side RQ here. So I'm going to know that KJ is 2 centimeters long and RQ is X centimeters long. Okay, and I'm going to say that is equal to the other corresponding side here. Okay, that side is 4 centimeters long over, that side would match up with this 6 centimeters long. Now, we just need to cross multiply and solve. So once again, 4 times x is 4x. 2 times 6 is 12. Now we just need to solve this equation. So we're going to divide by 4. We're going to divide by 4. And x equals 12 divided by 4 is 3. We need a label, so x would equal 3 centimeters. In other words, that piece right there is 3 centimeters long. In example 2, a totem pole casts a shadow 45 feet long. So notice the shadow of this totem pole is 45 feet long. At the same time that a 6-foot tall man casts a shadow that is 3 feet long. Write and solve a proportion to find the height of the totem pole. Now notice, with the totem pole and the man over here, 2 similar triangles are formed, because if I draw a triangle from here, okay, and down, okay, and then over here with the man, I can draw a triangle from here and down. 2 similar triangles are formed. So we're going to set up a proportion to figure out how tall this totem pole is. So notice this side x would match up with the man's height of 6 feet, so we can say the totem pole's height and the man's height compared would be equal to the other corresponding side. Okay, we have the 45-foot long shadow on the totem pole, and that would be over the length of the man's shadow. Okay. Now, we're just going to cross multiply and solve this to find out how tall this totem pole is. So I would do x times 3 is the same thing as 3x. And then here I'm going to have 6 times 45 is going to be 270. Now we just need to solve this, so I'm going to divide by 3. Divide by 3, and x is going to equal 90 feet. Okay, so notice here, what this means is this totem pole casting the shadow is 90 feet. Now in this problem, we have a forest ranger who is 150 centimeters tall and casts a shadow 45 centimeters long. So if I would draw a picture of that, okay, we have the forest ranger. Okay, he is 150 centimeters tall. Okay, and his shadow that he puts out here is 45 centimeters long. So if we'd cast a shadow there, it'd be 45 centimeters long. Okay, at the same time, a nearby tree casts a shadow. So we have our tree over here. Okay, and it says it casts a shadow that is 195 centimeters long. So here's where the shadow would go. It would be 195 centimeters. It says write and solve a proportion to find the height of the tree. So when we want to figure out how tall, okay, this tree is. And notice if we connect these, we get similar triangles. So we have the man's height, okay, the shadow, and we have a triangle. And over here we have the tree's height, okay, the length of the shadow, and to complete this triangle, we have 2 similar triangles. So once again, let us set up this proportion and solve it. So this side is 150 centimeters over this. That would match up with this side over here. We don't know this side, so let's put it as x equals. Now we need to have the other matching side, so that side is 45 over this side is 195. Now we are going to cross multiply and solve this. So let's cross multiply here. 45 times x is 45x equals 150 times 195 is 29,250. Now to solve this, we need to get the x alone, so we're going to divide by 45. We're going to divide by 45. And when we divide by 45, we end up with x equals 650 centimeters. Okay, so in other words, the height of that tree right there is, okay, 650 centimeters.